alphas and betas. So what we're doing here is we are taking two different angles, an angle of alpha and an angle of beta, and we're adding them together. Okay, so unfortunately, it is not just cosine alpha plus cosine beta. In other words, the distributive property does not necessarily work for these, okay? Rather, instead, we have very specific targeted identities that have been developed over time. And if you want to see the proof to how these work, it's in the book. It's a gnarly proof. So what we're going to do is we're going to take into consideration the fact that someone figured these out for us, and we're going to use them. And our goal today is to get comfortable using these trig identities. Okay. So the cosine of alpha plus beta is equal to the cosine of the first angle alpha multiplied by the cosine of the first angle beta minus the sine of alpha times the sine of beta. So notice it is not equal to just cosine alpha plus cosine beta. The distributive property doesn't work. So whenever we see a cosine of the sum of two different angles, these are two different angles, all we're going to do is plug into this formula. That's our alpha, that's our beta, that's our alpha, that's our beta. Okay? So all we're doing is applying a little formula today. So kind of back to our plug and chug. I don't like to use that term, but that's what we're going back to. So the formula for cosine alpha minus beta is cosine alpha times the cosine of beta, whatever that happens to be. And this is going to be plus sine alpha, sine beta. Now some of you used A and B or X and Y. That's okay. Alpha and beta, X and Y, they're just variables, so you're allowed to use that. All right, sine alpha plus beta is sine alpha times the cosine of beta plus the sine of beta times the cosine of alpha. And last one, sine alpha minus beta is sine alpha times cosine beta minus sine beta cosine alpha. All right, so here's what I want to point out to you, okay? Whenever you're dealing with a cosine function, of two angles being added together, as in the first one, or two angles being subtracted together, the cosines will match in the front. Okay? Cosines match. Whenever you're dealing with a sine function, like this one and this one, the sines in between will match, as they do there. But the ones in the front, each one will be different. Okay? Okay, so this example is asking to find the exact value for the cosine of 15 degrees. Well, unfortunately, 15 degrees isn't a really nice, easy angle to work with. However, we do have angles that are nice and easy to work with on the unit circle. One of those angles happens to be 30 degrees. That's an easy angle to work with, right? What are some other easy angles to work with on the unit circle that we know of? 45, 60, 90, 120, so on and so forth, right? 270. Okay, so that being the case, the question is, how do we create 15 degrees out of angles that we know how to use? Like 45 and 30 or 60? No?
Negative 35 plus 45.
Well, you said 35 minus 15? 45 minus 15? 45 minus 30, right? Oh, isn't it true that 45 degrees minus 30 degrees is the same thing as 15 degrees?
Yes.
And do you notice that that's a difference of two different angles? Ah, so we can use that, right? So instead, we're going to rewrite cosine of 15 degrees like this. We're going to rewrite cosine 15 instead as the cosine of 45 degrees minus 30 degrees. Because after all, 45 minus 30 is the same thing as 15. And 45 and 30 are nice, easy angles that we can work with. Now, this is a difference of cosines. So the 45 represents the first angle, which would be alpha. The 30 represents the second angle, which would be beta. So really, I have cosine of alpha minus beta. That's what I have here, right? Well, we have a formula for that. According to our formula, if I want the cosine of alpha minus beta, I'm going to be using this identity, the second one, because it's an alpha minus beta. Do you see that? Good. So it's going to be cosine alpha, cosine beta. So I'm going to write this all in. So it's going to be the cosine of alpha, which is 45 degrees, times the cosine of beta, which is 30 degrees. And is it a plus or a minus? Well, the formula says there's a plus sign between there. So I'll go plus the sine of 45 degrees times the sine of 30 degrees. Good. So far, so good, everybody?
Yeah.
All right, good. Now what we need to do is, do we have an exact value for the cosine of 45 degrees? What does it equal? What's the exact value for that? Very good. This is equal to root 2 divided by 2. What is the cosine of 30 degrees? Do we have an exact value for that? Huh? Yes, the cosine of 30 degrees is a root 3 divided by 2. Plus, what is the sine of 45 degrees? Very good. It is root 2 over 2. And what is the exact value for the sine of 30 degrees, everybody? It is 1/2. I'm so glad we're all on board with this now, okay? So simplifying even more, here's what I get. What is root 2 times root 3?
6.
That's the square root of 6. All divided by, what's 2 times 2?
4.
4, good. Then I have a plus sign between them. What is root 2 times 1?
Looks like root 2.
Root 2. And then I have 2 times 2. So this is all said and done, I get this. Root 6 plus root 2, all divided by the single denominator of 4. And you guys, that is my answer.
That is so good.
So therefore, the cosine of 15 degrees is root 6 plus root 2 over 4. Okay, here we go. Here's our next example. Let's find the exact value for the cosine of 75 degrees. Okay, so what we need to do, since 75 degrees is not on the unit circle, we need to come up with a clever way to rewrite 75. Holland, what do you got?
45 plus 30.
45 plus 30, is that true? Yeah, is that 45 degrees, right? Plus a 30 degrees? I like it. Is there another way that we could represent that? Yes.
I don't know if this is true, but 90 minus 15.
Yeah, 90 minus 15 is true, but 90 is on the unit circle, but it's 15? No, but 45 and 30 are, and that's why we like that. Okay, is there another one? How about 120 minus something? 120 minus 45, right? That's another way I could do it. Is there any other way we could do it? Okay, so the cool thing is, you guys, here's what I want to tell you. We came up with 2 different ways. One of them is an addition of 2 angles, and one of them is a subtraction of 2 angles. Guess what? Either one will work. That's the cool part. You can pick either one. So which one do you guys want to pick?
Addition.
All right, let's do it.
Your own adventure, kids.
So let's do the cosine. Let's rewrite 75 as 45 degrees plus 30 degrees. All right, I'm cool with that. So check it out. We want a cosine of 2 things being added together. So we're going to go ahead and use that identity up top because it's a cosine and it's of addition, right? So that's going to equal, for us, the cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. And where did I get that from, you guys? The toolkit, right? It's just right there. It says it right there. Cosine alpha, cosine beta, minus sine alpha, sine beta. No problem. Okay, good. So now, what is the cosine of 45 degrees? Root 2 over 2. Good. What is the cosine of 30 degrees? Root 3 over 2. Good. Minus. What's the sine of 45 degrees? Root 2 over 2. Good. What is the sine of 30 degrees? 1/2. Good. Let's simplify. Root 2 times root 3? Root 6. 2 times 2? 4. Minus root 2 times 1? Root 2. Root 2 times 2 is 4. So I get an exact answer of root 6 minus root 2 over 4. This answer, or any form of that answer, comes up a lot when we do these sum and difference identities. There we go. We have the sine of 7 pi over 12. Now, is 7 pi over 12 on the unit circle? No, it's not. That's an angle that we don't have on the unit circle. So we need to break up 7 pi over 12. That's the trick. Let's break it up into an angle that we can use. So can we rewrite 7 pi over 12 into something that's useful for us? Anybody see anything? Think about it. Seth, what do you see, buddy? Can you show me how you did that from the beginning, please?
Okay. So you can.
So 7 pi over 12.
You can turn 7 into 3 pi plus 4 pi.
Yeah, 3 pi over 12 plus 4 pi over 12.
Then that equals pi over 4.
Good. Simplifying that, that gives us pi divided by 4 plus pi divided by 3. Both of these angles are nice, easy angles to work with, right? So instead of 7 pi over 12, we're going to rewrite it as pi over 4 plus pi over 3. That's the very first step. So we're going to rewrite this. We're going to do pi over 4 plus pi over 3. So ladies and gentlemen, we are adding two angles together, and we're taking the sine of that. So we'll use the sine addition formula. So which one are we going to use, you guys?
The first.
We're going to use this one, right? It says sine alpha cosine beta plus sine beta cosine alpha. So here we go. This is going to be the sine of pi over 4 times the cosine of pi over 3 plus or minus? Plus the sine of pi over 3 times the cosine of pi over 4. So moving along here. So what's the sine of pi over 4? Root 2 over 2. Very good. What's the cosine of pi over 3? 1/2. Very good. Plus, what's the sine of pi over 3? Root 3 over 2. Good. Times the cosine of pi over 4? Root 2 over 2. Simplifying, I get root 2 over 4 plus, oh, there's that answer again, root 6 over 4, which is a root 2 plus a root 6 over 4. They will not all be that. Okay, and today I'm more concerned about the process than the answer. Okay?
Is it just because of cosine?
It just happens to be the nice, easy angles that we're choosing to break them up with, okay? They will not all be that, okay? Promise. Yes. So we're starting with the right-hand side, and you're working backwards. So this part represents our alpha. So alpha was 50 degrees. This part represents our beta. So beta was 5 degrees. So is this a sum or a difference? It's a difference. So this is equal to, is it cosine or sine? It's a cosine difference. So it's going to be the cosine of 50 degrees minus 5 degrees. So it's a cosine 50 minus 5. Okay, keep working with this. So we've identified alpha, we've identified beta. 50 minus 5, everybody?
Cosine of 45 degrees.
Very good. So this is now equal to the cosine of 45 degrees. And then it says, what's the exact value?
Root 2 over
And we all know the answer is root 2 over 2. So therefore, you guys, all of this stuff right here,
Oh wait, that's actually not that bad.
I know,
We're gonna have to go back into it.
is equal to that right there.
This is so much better than last night's homework. I feel like he gave us last night's homework.
You only have-
Is this free?
Alright, so where's my, there we go. Okay, so we're gonna rewrite cosine alpha minus beta as cosine alpha times the cosine of beta. Plus or minus, everybody? Plus, very good. Sine of alpha times the sine of beta, all divided by our common denominator, which is sine alpha times sine beta. Now we're trying to make it look like the right-hand side. Okay, so all we did was we applied the difference identity for cosine. So we have a single denominator, and we have two pieces on top of the numerator. Yeah, Seth, what should we do? Yeah, let's split up. That's a great idea. So if we split this up, here's what we get. We get cosine alpha, cosine beta over sine alpha, sine beta, plus sine alpha, sine beta over sine alpha, sine beta. Exactly. So here's what I want to point out to you. What's a cosine alpha over a sine alpha? That part I highlighted. How much is that?
That's cotangent.
Yeah, that is a cotangent for alpha, right? Now in a different highlighter, how about blue? What's a cosine beta over a sine beta? That's a cotangent beta, right? So now we have a cotangent of beta plus, how much is that, all that stuff over there? That's equal to 1. Yes, so we can use these in establishing identities as well. All right, because sine alpha, sine beta over sine alpha, sine beta is just equal to 1. So you can use these in establishing identities. You guys try it on your own. I'd like you to find the exact value for sine of 5 pi over 12. Okay, everybody, here's what I got. I broke up into 3 pi over 12 plus 2 pi over 12. And that gave me pi over 4 plus pi over 6. Does not matter. You could also rewrite it as pi over 6 plus pi over 4. Either way, when you plug into the sum and difference formula, you should get pi or root 6 plus root 2 over 4. Again, that answer comes up. That's the last time we'll see that one for this lesson, I promise. But who was successful in coming up with that answer? Hands up. Let the record show, I'd say 65% of the class got that right. Oh, there's more. 80% of that class got it right. 90% of the class.